there are several concepts that you need to know as far as calculation of the volume flux and the mass flux is concerned. The first one is what we've always been saying, how to calculate the volume flux and how to calculate the mass flux. Their calculation becomes simpler if you know how to define the mass flux, how to define the volume flux. So just from the definition we know that a volume flux is the volume of a fluid that passes through a given section of the tube of flow per unit time. So if we have that volume of the liquid that passes through a given section of the tube of flow, then we have the time, then volume of the time now will give us the volume flux. That is it. Then also we can derive another way in which we can calculate the volume flux. Also, after knowing how to calculate the volume flux, we need to go ahead because now volume flux is a physical quantity. So we need to find the units for the volume flux. Look here. If that is the section of the tube of flow and the liquid is flowing from section A to section B. So the volume here, because a tube is having a cylindrical shape, so how to calculate the volume of the fluid here is actually cross-section area in this part. And remember, A can be given by pi r square. But now, because we know that it's already pi r square, we just leave this. Now, which you multiply by this distance from here up to this part. Now, this one will be the volume. That one will be the volume flux because cross-section area times d will be the volume. But the volume flux says what? Per unit time. So we need to divide here over t. But from what we know, displacement over time will be velocity. So where we have d over t is v. So volume flux is given by A, then d over t or v. So AV is the formula for calculation of the volume flux. Cross-section area you multiply with the velocity of the fluid. That is where we have derived from up here up to here. Now let's look at the units of volume flux. After calculating, what will be your units? Because you cannot leave it hanging. Units in physics has marks. If you leave it, you lose a mark. If you give wrong unit, you still lose a mark. So we can get the units from the values here. Now that cross-section area is given in meters square and velocity is given in meters per second, so it's like meters square for cross-section area, you multiply by velocity is given in meters per second, which is like saying of a second. So whatever we are going by the end of by the end of the day is going to be m cubic per second. These now are the units for a volume flux. So volume flux is given in meters cubic per second. So whatever you calculate, if this volume flux, please give it in meters cubic per second. At some ways, you're also allowed to give in centimeters cubic per second. So this is the volume flux, meters cubic per second. Now, let's look at the mass flux. We say that mass flux is the mass of a fluid that passes through a given section of the tube of flow per unit time. So when you have the mass of the liquid and then the time that it takes that mass of liquid, a given mass of liquid to flow, then you can get the mass flux. But the easiest one is, we always know that densities is given by mass of a volume. So if mass is the mass flux and volume is the volume flux, then mass flux now would be given by volume flux times the density. And we know very well that volume flux is AV times the density. So if you want to get the mass flux, you simply multiply the volume flux with the density of that fluid, or if it's a liquid, or of that liquid. Now, what are the units of mass flux? What are the units of mass flux? Let's look. Let's look at the units of the mass flux. After calculating mass flux, what are you supposed to write as the unit? Because I said every physical quantity must have a unit unless it is a ratio. So, remember, we multiply volume flux times the density. And we know very well, volume flux tumeelewana it is meters cubic of a second. Now, we are multiplying it with density. Remember, density is given in kilogram per meters cubic. Now, this meters cubic will cancel each other, so we have kilogram per second. Those are the units, or that is the unit for mass flux. After calculating whatever you are calculating, if this mass flux, put the correct units. How we penalize the whole of physics, regardless of the topic or the concept. You give wrong units, we deny you a whole mark. You give no units, we deny you a half a mark. So let's look at this question here. It is noted that 250 centimeters cubic of fluid flows out of a tube whose inner diameter is 7 millimeters in a time of 41 seconds. What is the average velocity of the fluid in the tube? What is the average velocity of the fluid in the tube? First of all, we have the volume, which is 250 centimeters cubic. We have time as 41 seconds. So from the two alone, we can get what we call volume flux. Because tulisema a volume, we say that volume of a time, or a volume by unit time in a given section, give us the volume flux. So we are well to go now. We can get our volume flux. But also, we need to be very keen when it comes to the units. Can we proceed when it is in centimeters cubic? Or we can convert it to meters cubic? Any can do. But let's convert the volume into meters cubic. Most of you don't know how to convert it, but it's very simple. Like, if 1 meter is equivalent to 100 centimeters, 1 meter square is equivalent to 10,000 centimeters square. Now 1 meters cubic would be equivalent. Now we multiply by the zeros by 3. Add another 0. Centimeters cubic. Well, so this is what we are using. So for us to convert this into meters cubic, simply divide by a million. Simply you just take it 250 centimeters cubic, you divide by a million. The answer you will get, you divide by 41 seconds, so that we can get the volume flux in meters cubic per second. Now, taking my calculator here, 250 centimeters cubic divided by 10, a million. Yes, we have 2.5. I can write it here. Now our volume in meters cubic is going to be 2.5 times 10 power negative 4 meters cubic. This is the volume. Then we say volume flux is equals to volume over time, which is 2.5 times 10 power negative 4 meters cubic over 41. So we get the time over there. So we simply take our what we have there, we divide by 41. So we have 6.09 76 meters cubic per second. Meters cubic per second. That is the volume flux. That is the volume flux. But the question is not asking about the volume flux. The question is asking us what is the average velocity of the fluid in the tube. What is the average velocity of the fluid in the tube? This volume flux is given by A1, I mean just AV. This one should be the volume flux, which is now 6.0976 times 10 power negative 4. Oh, so sorry, power negative 6 here. Power negative 6 meters cubic per second. Even here, it should be times 10 power negative 6 meters cubic per second. Now, this is what we have, and they're asking for the velocity, meaning what? We should have the cross-section area. We should have the cross-section area. So, where can we, or how can we get the cross-section area? We have the diameter of the pipe. We have the diameter of the pipe. So, in a very simple term, we can get the cross-section area. Again, we have been given in terms of millimeters, which is not rhyming with what we have. We have done it in meters cubic, so even the cross-section area should be given in meters square. So very simple. What we are supposed to do here is this. If this is the diameter, then the radius should be 3.5 millimeters. 3.5 millimeters. Then cross-section area is pi r square. Pi r square. Now, our radius is equals to 3.5 millimeters. We can make it meters. We simply divide by 1,000. We make it meters. So 3.5. Then we divide it by 1,000. We get what? I want you to learn how to use your calculators very fast. 3.5. We divide it by 1,000. So in power form, it's going to be 3.5 times 10 power negative 3 meters. That is now the radius. But we want the cross-section area. We want to get the cross-section area. So it's going to be pi, which is now 22 over 7, times what? Times the radius square, which is 3.5 times 10 power negative 3. Now square. So this is the cross-section area times velocity should give us 6.0976 times 10 power negative 6. So in short, velocity should be 6.0976 times 10 power negative 6. We divide it by what we all have in this other side. So you see now, we can get the square of this. We multiply it by 22, then we divide it by 7. Or we simply have this. We can make it very simpler. We just say we square it, the answer, times 22, divided by 7. So here, we are going to have 3.85 times 10 power negative 5. V should be equal to 6.0976 times 10 power negative 6. So our V is going to be 6.0976 times 10 power negative 6 over 3.85 times 10 power negative 5. So what will you get over there would be the velocity. Now let's see. So we are going to have this. The whole of this you put in brackets, then you divide by 3.85 times 10 power negative 5. Also in bracket. 6.09 times 10 times 10 6.0976 times 10 power negative 5 negative 6. You close the bracket, you divide by 3.85 times 10 power negative 5, still you get 0.158. I would put it into 4 significant figures. 4 meters. It's velocity, so it's meters per second. So that is the velocity that fluid should be having, 0.1584 meters per second. Just follow the steps, get there.